Okay, we're back. As promised, here's part two, where we actually go under the hood and explore a little bit more about what's happening with the cosine similarity test. And obviously, you're going to see the code. I'm going to show you in real time and explain what things do without getting too nerdy about it all. And hopefully, this can provide lots of value to people providing AI services and give a little glimpse into what a cosine similarity test looks like. So, first of all, we got a blank VS Code slate here. Let me just clear the terminal. Now, I copy and pasted this piece of data so this video isn't too long. And essentially what this is doing, I'm importing the sklearn library, as you can see here, machine learning module for Python, free, open source, just amazing, makes it super accessible to everyone to give this a try. And we're just importing the vectorizer and the cosine similarity, which are the two packages that we will need to do this. And then we have a list right here named sentences with a bunch of like dummy text in it. So essentially, if we were actually performing this test, what we would do is get the business owner to provide 10 ideal responses to questions that a user may have. And then we take those 10, put it in here, and then we compare them to 10 that the bot is producing or the language model is producing to those questions, and we compare the ideal outcome with the outcome that the bot is spitting out. And ideally, we just try and match them up as close as possible to provide ultimate satisfaction for the client and just get the language model doing what we want it to do. So we can start TF-IDF. TF-IDF stands for text frequency inverse document frequency, and we're going to make a variable, if I could spell text vectorizer, and we're going to set that equal to this. So we're just creating an instance of the TF-IDF vectorizer class here so that we're actually able to use all that comes with the package. Now, after that, we're going to actually want to create the matrix TF-IDF. And now these are just variable names. This is just what I'm calling this, just because it makes sense, but these can be whatever you want them to be. So now we're going to actually create the matrix, which is essentially going to be a numerical relation of all of the sentences in a matrix so that the computer can actually read through them and calculate the cosine similarity later on. So the matrix is going to be the variable we said earlier, the vectorizer variable, dot fit transform. So we're going to use the fit transform method that comes with the vectorizer package, and we're going to use that on the sentences list. So now we're actually turning the sentences into those numerical chunks of data that the computer will need to calculate these angles. So, okay, great. That's good so far. Next step, we're going to want to use that matrix and actually start calculating the cosine similarity. So we'll just call this cosine sim equals the cosine similarity of that matrix. So now it's using the data in the matrix, all the sentences, and it's actually going to use the cosine similarity module now to break it down and analyze the relationship between the text. So now, next up, we can, what can we do next? Use the cosine sim. So it's going to be sim score or something like that. So now we can do the cosine sim, and we're going to need to actually pull out the indices from sentences to compare them. So say we wanted to compare these first two, the quick brown fox jumps over the lazy dog. Probably all heard that line before. And obviously they're identical sentences. So when we compare them, 0 and 1. Now, Python is a zero-based index language. So the first item in a list is always going to be item 0. So that's why I put 0 there. So we got the sim score, and then we can print the sim score right here. Perfect. We got a clear terminal. Now, if we run this, we see that we get a 1, lots of zeros, and a 2. But for rounding's sake, we'll just call it a 1. Now, a 1 means that they are perfectly similar sentences, which makes sense. Now, we can see that just using our eyes, but the machine also lets us know that in a 3D space with all these vectorized components, it also agrees that they are perfectly similar. So we're off to a good start. Good. So now let's say we wanted to compare this first one here with this third item in the list. To us, they're similar. Speedy red fox leaped over snoozing hound. We'll kind of put them in the same box and categorize them in a similar way. However, you'll see when we run the test that the machine doesn't quite think so. So boom, run the test, and you'll see we get 0.1998. Now, it's not 0, so it's between 0 and 1 generally. There can be cases when it's -1, but we're dealing with 0 and 1 right now, 0 being completely dissimilar, 1 being perfectly similar. So you can see there's some similarity. 0.19, they're somewhat similar. So, for example, the ideal outcome we want to achieve for a client is between 0.6 and 1 normally. Now, anything below 0.4, you can probably improve the model and fine tune it a little bit. So 0.5, 0.6, and 1 is always what you want to aim for. So now we'll just do one more test where we'll compare the first item in our list to, say, the 6th or 5th item here. So cooking a delicious meal is an art form. And the fox is what we're comparing. So now if we run this, we can see it gives us a 0. So they're essentially perfectly dissimilar sentences. Now, that's good. That checks out. We can visualize it with our eyes, and also the vectorized data lets us know that our assumption was correct. Now, essentially, this is one of the best techniques to just quantify to a client that we're actually just, using math and data to figure out these results and to fine tune the model. It's really easy to get lost in a lot of the technical jargon with AI and what's happening, but this is just a very tangible way. 0 and 1, very simple. So, I definitely encourage you to use this test. Super helpful if you're developing AI technologies and showing clients AI solutions. And we've seen a lot of success with it, and people seem to really get a lot of value from it. So hopefully this video provided some decent value for you. And that'll be all. I'll put the code in below the video. I was going to say in the description. It's not YouTube, it's LinkedIn. Okay. Cheers, guys. Take care.